going to start our chapter number 1, which is rational number. So, as you know, you have already studied about rational numbers in class 7. So, what is rational number? Rational number is the number which is in the form of P by Q. Means that, for example, 2 by 3. This is the rational number. Let's take another example like 4 upon 5. This is also a rational number because this is in the form of P by Q. Now, there's one doubt like 6. Is 6 is a rational number? Yes, 6 is a rational number. Why so? Because when we put 1 in denominator, we can see that 6 is also a rational number. Now, let's take another example is minus 7 upon 3. It is a rational number? Yes, it is a rational number. Minus 7 upon 3 is also a rational number. Why? Because minus and plus, both negative and positives are rational number. When they are in the form of P by Q. Okay. So, another example here we can see that 2 upon 0. It is also in the form of P by Q. So, but this is not a rational number. Why so? Because when we solve this number, its answer is infinite. This is not a rational numbers. So, here condition is P by Q form is a rational number, but condition is Q is not equal to 0. Q is not equal to 0. Means that denominator is not equal to 0. Okay. So now here one thing is 0. Is 0 is a rational number? Yes. 0 is also a rational number. Okay. This is also a rational number. Now we are going to start the property of rational numbers. So in closure property, first of all we have to know about closure property. What is closure property? Basically there is 4 operations like addition, subtraction, multiplication and division. About closure property of rational numbers. First we have to check in addition. Okay, so addition, that 2 rational number, the sum of 2 rational number is also a rational number. Okay, let us check. Like first is closure as addition property. The 2 rational number sum is also a rational number. Let us check. 2 upon 3 plus 3 upon 3 equal to what? 5 upon 3. Yes, the sum of 2 rational number is also a rational number. That means closure in addition. Closure in addition. Okay. Now let us check it subtraction. So subtraction. This is. Let's take another example. Here is minus sign. That means the rational number. These 2 rational numbers subtraction is also a rational number. Let's check. Like 2 upon 3 minus 4 upon 3. So what is the number is? Minus 2 upon 3. That means this is also a rational number. So the property of subtraction is also belongs in closure property. Let's take another example, multiplication. So the product of 2 rational number is also a rational number. Let's check. Let's take one example. 2 upon 3 multiply 5 upon 2 is equal to 5 to 10, 3 to 6. 10 upon 6 is also a rational number. That means, yes, multiplication is also belongs in closure property. Now, let us check in division. So, division. When we divide 2 rational number, the result will be rational number. Let's check in division also. So, let's take 2 upon 3 divided 0 upon 1. So what is this? 2 upon 3, 1 upon 0. So you know that this number is infinity. So we cannot say that division under closure property. So division under closure property is wrong because there is 0 and the answer will be infinity. So this is not belongs in closure property. Okay. Let us check another property. We can see here commutative property. The commutative property, let us check addition, subtraction, multiplication and division. Okay. So let us check in addition. So what is commutative property? As you know, a plus b is equal to b plus a. This is a commutative property, right? In rational number, a upon b, c upon d equal to c upon d plus a upon b. This is commutative property. Let us take example. So 2 by 3 plus 1 by 3. Okay? And what is the answer? Yes, 3 by 3, right? And just opposite. 1 upon 3 plus 2 upon 3. So what is the answer? 3 upon 3. So both are correct. Which order is right? So right, like first digit, second digit से addition करिए, याद है? The second digit or first digit addition. So both are correct, right? 3 upon 3, 3 upon 3. Yes. So commutative property under addition under commutative property is yes. So let us check in division also. So when we divide two rational number and then to change the order, is the answer is same or not? Let us check. Here 1 upon 4 divided by 3 upon 4. So what is the answer? 1 upon 4 into 4 upon 3. So 4 cancel out, 1 upon 3. Now the order will be changed. 3 upon 4 divided by 1 upon 4. Let us check the answer. 3 upon 4 multiply 4 upon 1. So 4 cancel out. Here is 3 upon 1. So these are changed. 1 upon 3 and 3 upon 1. That means division under commutative property is totally wrong. Clear? Let us see in associative property. So first we check addition. Do you know addition? What is associative property? A plus b plus c equal to a plus b plus c. This is associative property, right? First we solve this and add, and then solve bracket and then add. So in rational number, similar associative property is like a upon b plus c upon d plus e upon f. So now equal to a plus a upon b, c upon d and e upon f. So first we'll solve this and next point is this. Okay, so let's take one example. A plus a upon b, like 2 upon 3 plus 1 upon 3 plus 4 upon 3. Okay, solve first this. Okay, so what is 2 upon 2 plus 1 is 3, and then open the bracket and solve this number. So 3 plus 4, 7 and upon 3. That means this side is 7 upon 3. Now check the next point, that is solve this first and then this number. So solve 4 1, 5 upon 3 plus 2 upon 3. What is the answer? Yes, 7 upon 3. That means both are equal. That means addition under associative. Okay, now take in subtraction. Let us check in subtraction. So apply here minus, because minus subtraction property, the associative property is some addition, subtraction, a upon b minus c upon d minus e upon f. First we'll solve this, and then in the second part this. So in left hand side, first to solve left hand side. So take one example, 2 upon 3 minus 1 upon 3 minus 4 upon 3. What is the answer? 2 minus 1, 1 minus 4 upon 3. So what is the answer? Minus 3 upon 3. Now solve right hand side. So 2 upon 3. First we'll solve 1 upon 3 and 4 upon 3. So here is yes minus 3 upon 3. So minus minus plus. Okay. So plus. The 2 plus 3, 5, 5 upon 3. That means both are not equal. LHS is not equal to RHS. That means subtraction are not an associative property. Okay. So subtraction cancel out. Now let us check another property. Another point is multiplication. Is multiplication under associative or not? Let us check. Let us check in multiplication. So multiplication, a upon b multiply c upon d multiply e upon f. So now next is similar. Solve this first. Okay. Let's take one example. So in associative property, 1 upon 2 multiply 3 upon 2 multiply 2 upon 1. Okay. Solve this first. So what is the answer? 2, 2. That means cancel 3 upon 1 into 1 upon 2. 3 and 2. So left hand side 3 upon 2. Now check right hand side. 1 upon 2 upon 3 upon 2. First we'll solve this one, and now 2 is 2, 4 into 2. Now cut. So 3 upon 2. Yes, both are equal. Left hand side and right hand side are equal. So multiplication is under associative. Okay, is also true. Okay. Now check in division. Okay. So check that division into associative, yes or no. So now take one example. 1 upon 2 divided 3 upon 2 divided 2 upon 3. Okay. Let's check. What is the answer? 1 upon 2 divide change. The sign is changed into multiplication, and 2 by 3 divided 2 by 3. Now 2 cancel out. 1 upon 3 multiply 3 upon 2. Okay. So 3 cancel. What is the answer? 1 upon 2. Okay. Let's check the form again. So answer is 1 upon 2. Clear? Now first we'll solve this order. Okay. So 1 upon 2 divided 3 upon 2 multiply 3 upon 2. Okay. So 3, 9 into 4. Again 1 upon 2 divide change into multiplication, and 4 upon 9 reciprocal it. What is the answer? 2 1 2 2 by 9. So before you're going to start, that answer is totally different. That means left hand side is not equal to right hand side. That means division is not under associative, right? So these are not equal. Okay. So let's take another property. Let us see distributive property. So distributive property is like sum A plus B plus C equal to A plus B, A and then A plus C. This is distributive property. So under rational, A upon B plus B upon C plus C upon D plus E upon F, and equal to A upon B plus C upon D plus A upon B plus E upon F. Okay, this is distributive property. Now take one example. 2 upon 3 plus 1 upon 3 plus 4 upon 3 equal to 2 upon 3 plus 1 upon 3 plus 2 upon 3 plus 4 upon 3. Okay, solve this and find out the distributive property under addition or subtraction is possible or not. Okay, so now let us see about distributive property in multiplication and division of multiplication over addition for rational numbers. So this is like this: C upon D multiply E upon F, and separate. Here we take addition G plus upon B into E upon F. Okay, so let us check. Let's take one example, which is 2 by 3 into 1 upon 3 plus 4 upon 3. Okay, what is the answer? When we solve these two-digit number, here is 2 upon 3 multiply 3, denominator having 3, and 4 plus 1, 5. Okay, so now 5 into 2, 3 into 3. What is the answer? 10 upon 9. Okay, so now take separate form like this. Now separate what? 2 upon 3 multiply 1 upon 3. Separate. Okay, 2 by 3 into C, A by B upon into C upon D. So take 2 into 3. Separate हम लिखेंगे. 2 ones are 2, 3 threes are 9. And here A by B into E upon F, like 2 by 3 into, what is the third digit? 4 upon 3. So 4 twos are 8, 3 3, 9. Now add these numbers. 2 upon 9 plus 8 upon 9. So 2 plus 8 to 10. 8 plus 2, 10 and 9. So 10 upon 9 and 10 upon 9. Both are equal. That is distributive property under multiplication. Okay. So hope you all understand about the property. What is additive inverse? Additive inverse. Let us take one example. A upon B. What is the additive inverse of A upon B? Is simply minus A upon B. That means just inverse, opposite. Now take one example. 2 upon 3 is additive inverse is minus 2 upon 3. Okay. Now what is the inverse of this number? Tell me, additive inverse of this number? Yes, absolutely right. 3 upon 4. This is the additive inverse of these numbers. Means sign will be changed. Representation of rational numbers. If your question is minus 2 upon 5. So where the rational number minus 2 upon 5 is represent on number line. So let us check. First we will divide these numbers. So 5 divided by 2. 2 is divided by 5. So 0. What? 2. Then apply here 0, 5, 4, 20. That means this is 0.4. 0.4. That means we know that the number, this number minus 2.5 is lie between 0 or 1. Okay, minus 0 or minus 1 because there is minus sign. So now as you know what is number line, right? Here we take 0, here negative integers and here positive integers, right? So here 1, 2, 3, 4 like this, minus 1, minus 2 like this, right? This is the number line, right? So now represent minus 2 upon 5. So take 0, minus 1. Here is 0.1, 0.2, 0.3 and 0.4. That means the number exists here. Minus 2 upon 5. Okay, 0.4. So this is very simple, and when we solve in question, then we know all about this representation. This is a simple example I told you. And now let us start exercise. More example of representation rational numbers. So the example is minus 8 upon 5. Okay, so check. First we will solve. So 5 ones 5, 3, 0.6. So means 1.6. Then means minus 8 upon 5 is lie between 1 and 2. So draw a number line and represent this. Here is 2, here is 0, 1, 1.1, 1.2, 1.3, 1.4, 1.5 and 1.6 and so on. So minus 8 upon 5. Here this representation here.